All right, a 20 kilogram tennis ball launcher shoots a 0.057 kilogram ball across the court. If the final velocity of the ball is 36 meters per second to the north, what's the velocity of the tennis ball launcher? So the tennis ball launcher has applied a force to the ball in order to accelerate and get the ball moving at 36 meters per second. So the ball also had to apply an equal force onto the launcher. So the momentum of the ball is going to be equal to the momentum of the launcher. Now, the momentum of the ball is equal to the mass times the velocity, 36 meters per second. And so our momentum is equal to 2.052 kilograms times meters per second. So we set that up. We know that that's the momentum of the ball, so it also has to be the momentum of the launcher. So the momentum of the launcher is equal to 2.052 kilograms times meters per second, which is equal to its mass times its velocity. So 20.0 kilograms times the velocity of the launcher. So we divide both sides by 20 kilograms, divide by 20 kilograms, and we get that the answer is the velocity is equal to 0.103 meters per second. It's in the opposite direction, so negative. Next one, number 4, 0.008 kilogram bullet, 400 meters per second, hits a tin can filled with sand, a mass of 5 kilograms, gets stuck inside in an inelastic collision. Assuming there's no friction, how fast is the can and the bullet moving after the collision? So we've got the momentum of the bullet plus the momentum of the can is equal to the momentum of this new bullet can combo. So we know that the can is still, so there's no velocity, so the momentum of the can, if it's 0, mass times 0 is going to equal 0 momentum for the can. So the momentum of the bullet is equal to 0.008 kilograms times 400 meters per second. And that is going to equal 3.2 kilograms times meters per second. So that's the momentum of the bullet. Now that is also going to be the momentum of the bullet can combo. So we set this equal to the mass of the bullet can combo. So that is 5.008, 5 kilograms plus 8 grams, 0.008 kilograms, gives us 5.008 kilograms times the velocity of our combined object. So here we go ahead and divide both sides by 5.008 kilograms. That cancels out. Divide by 5.008 kilograms. And we get 3.2 divided by 5.008 is 6.4. Velocity equals 0.64. This is kilograms times meters per second. Meters per second. All right. Next, 110 kilogram running back carries the ball south at 8 meters per second. 130 kilogram linebacker runs to make the tackle going north, 5 meters per second. In their collision, the linebacker wraps his arms around the runner and makes it an inelastic collision. How fast are they moving right after the collision? So we've got the momentum of the running back plus the momentum of the linebacker equals the momentum total. So we'll do the running back's momentum first. We've got 110 kilograms times 8 meters per second, plus the linebacker is 130 kilograms times, now here's the key right here, north, the opposite direction. So we'll give this a negative 5 meters per second because one is coming this way, heading south, and the other is coming this way, heading north. So they're opposite directions. We have to indicate that with a negative sign on one of their velocities. It won't make a difference which one, but it has to be there on one of them. All right. So this is going to be our total momentum right here. We'll go ahead and simplify and solve this equation. So these multiply together to get 880 kilograms times meters per second, plus this will be 650 negative kilograms times meters per second. Just clean that up. Times meters per second. That equals the momentum total. So you add this up and you get that it is equal to 230 kilograms times meters per second. So that's your total momentum between these two are added together. So we look at their two masses. The momentum is going to equal the mass times velocity. So substitute in here 230 kilograms times meters per second is going to equal the mass. So we have the mass here, 130 plus 110 equals 240 kilograms times the velocity. Divide both sides by 240 kilograms. That'll cancel. Divide this by 240 kilograms. And this, the velocity is equal to 0.96 meters per second. So in this one, we need to find the velocity or the momentum at the start, and it needs to equal the momentum at the end. So let's do one equation here. At the start, this is our SUV at 2,000 kilograms. This is our velocity at 7 meters per second. So 2,000 kilograms times 7 meters per second plus 800 kilograms times sitting at a stoplight. So that's 0 meters per second. And that's going to equal the velocity at the end, the momentum at the end. So we need the momentum of the SUV. So we know that the SUV is 2,000 kilograms. And momentum would be times velocity. That's what we need to solve. Plus the momentum of the car, which is 800 kilograms times, so that's here, 7 meters per second. Right? Times 7 meters per second. So we'll simplify this. This is 14,000 kilograms times meters per second plus 800 times 0 is 0, so plus nothing, is equal to 2,000 kilograms times velocity of the SUV plus 800 times 7, 5,600 kilograms times meters per second. Subtract 5,600 kilograms times meters per second on both sides. Minus 5,600 kilograms times meters per second. And this gets us that there's 8,400 kilograms times meters per second is equal to 2,000 kilograms times velocity of the SUV. Divide by 2,000 kilograms on both sides. Divide by 2,000 kilograms. Kilograms cancels out, leaves us with meters per second. And we simplify this, and at the velocity of the we find that the velocity of the SUV is equal to 4.2 meters per second. In this last problem, we have Teresa and Samir with their bumper cars, and here it's really important to get your positives and negatives correct because they're heading in opposite directions. So we've got P1 plus P2 equals P1 final plus P2 final, and in this case P1 is equal to let's do Samir at 130 kilograms. And let's clean this up here. Samir, 130 kilograms times his velocity, which is 3.5 meters per second. And then that's going to add that to Teresa's mass, 110 meters per second. 110 kilograms times 3.0 meters per second, and that is going to equal, there's one key step here. This is negative. We need to make sure that we do one of these as negative because they are heading in opposite directions to one another. So then we have the velocity final of Samir is 130 kilograms times 2.4. Now Samir's going the other direction. He started out positive, now he's bouncing backwards. He's going backwards now, meters per second, plus 110 kilograms times Teresa's velocity final. This simplifies out to 125. When you do all these together, it's 455 plus negative 330, and then you get 125 kilograms times meters per second is equal to negative 312 kilograms times meters per second, and plus 110 times velocity final. Next, we add 312 to both sides. We add 312, and we end up with 437 kilograms times meters per second equals 110 kilograms times meters velocity final. Divide both sides by 110. Divide by 110. And we get that the velocity final is equal to essentially 3.97 meters per second. All right, I'm just about out of time with this video. Read this last question carefully. There's a trick to it, and the cue ball's mass, the little trick is going to be that the final mass of the cue ball is the mass of the cue ball is 0.17 kilograms. Read the question, see if you figure out the trick.